Let's now review the part 2 of the material for our exam 2. Looking at pointers. What is a pointer? We discussed the pointer is a special type of variable that contains a memory address. Different from all normal variables we're used to, it doesn't contain a value that we can immediately use, just an address for another variable. Given the following memory content, let's get some questions answered. So here's the memory content on the right, where it shows the address locations and the content of memory. So we have 2, address 2, we have 20, address 222, we have a 2, and that's an integer pointer. So if we see out the content of int ptr, what do we output? So it's whatever inside of that, which will be a memory address. In this case, it has 2. Now, if we see out the content or the dereference, so you see the asterisk in front of the name of the pointer, is going to be the dereference, which will be indirecting access the memory location 2. So what the memory location 2 contains 20. So if we do a dereference, we're going to output 20. Now, if we output the address of int ptr, is the address memory of the pointer is 222, right? Here it is. Now, what if we add another variable here, int var, memory location 4, and the content is 8. So if we want to put the address of int var, is the memory address there is 4, right? Now we want to output the content of int var. Content of int var is 8. How about how you would pass a pointer int ptr into a void function called myfunc? So void myfunc, then you indicate there's an integer pointer by indicating the asterisk in front of the pointer. Now if we want to do the same thing, but instead of passing by value, we're going to pass by reference. So as any other function, we're just going to add the address operator in front of the pointer. Continue with pointers here. We need to know how to access the member of a struct using pointer. So which operator do we use it to do that? We talked about it before. We're going to use the arrow operator, right? We have the pointer, arrow, and then the name of the member. Like if it was a student, so and we're looking for name, so it will be a ptr-name or arrow name. So what if we want to access a pointer member that is pointing to something? Say for example, we want to access the next pointer on some struct. So we'll see ptr, arrow, next, arrow, and then the member. So it's going to look at 2 reference of in front. So it would be ptr dash arrow, next, arrow, name. We want to be able to create a linked list, which is the primary focus of this test, and that linked list would be possible add from a file, or we just want to add a new node on the list. And then what we learn here is that we can add to the front or we'll be able to add to the back, as we learn it, that we'll do for a queue, right? So we also need to know how to search in a linked list, which we've done that for our assignment. When we search, what type of loop do we use? Remember, we use a while loop to do that. And what the loop should check for. There was 2 things we will check for. The first one is if we had reached the end of the list, and then the other one is if we found what we're looking for. So we haven't reached the end of the list, and that will have the pointer that we're using to search is different from null. Once c is equal to null, we reach the end of the list, and then we have a found. So while not found and ptr different from null. Looking at linked list, let's define a struct that we're going to call DVD node that contains a title, genre, and running time in minutes that would be used in the linked list. So when we say that we're going to use in the linked list, we need to include a pointer of the same type, and we usually call that next. So title, it would be a string, genre will be a string, the running time will be an integer. So here is our struct. So struct DVD node, string for title, string for genre, int for time, and we're gonna have a pointer next that is point to a DVD node, same struct. So now we want to create an empty list to this node that we defined above. So in order to do that, we said that we'll create a pointer that we call next of the DVD node type, and then make that equal to null. Here is DVD next pointer head, and head is equal to null. So now we want to create an instance to add to this linked list. So basically we're going to use a new to allocate dynamic memory. So we create an auxiliary pointer, and then we use a new to create a struct. So we create here DVD movie pointer, DVD node movie pointer. Then we use that to create a new. So DVD movie PTR is equal to new DVD node. Let's talk about ADTs. What is an ADT? That stands for abstract data type. The difference as a standard data type here, we do not define the implementation as we define implementation of an integer, a float, what we put inside and how we manage that. Here so we're going to only define the operations that I have associated with that data type. That's why we call it abstract. So what is a stack? That's one of the types of ADT we have learned. Stack is an ADT where we add all the elements in the front of the list and remove from the front. So all the actions happen on the front. What is LIFO stands for? So last in, first out. So that represents a stack. So whatever comes in last is whatever's coming out first. Okay, true or false? FILO is opposite of LIFO. So first in, last out is the opposite of last in, first out. Now it's exactly the same thing, right? It's synonymous. So that's false. What logic represents a stack? So we talk about that is the last in, first out. So true or false? Stacks can only be represented using linked lists. Now that's not true, right? We've done discuss in class that we could use arrays also. They may be not as easy to implement, but we can also use array. Now we want to be able to answer the same questions for queues. So let's go back to the top. What is a queue? A queue is an advanced abstract data type where we'll add from the back and remove from the front. So the logic would be first in, first out. So whoever comes in on this, the queue is like a line on the market. So the first person that comes into the line is the first one that's going to be getting out. So first in, first out. So that's what it represents as stack. So stack can only, or queues can only be represented using linked lists. That's false too. We see an implementation using an array. So let's talk about validate input. So what loop should be best suitable for error check input? Remember we discussed that? It would be a do while loop. The reason being is that we're gonna force to run and input at least one value from the input, and then we check that. If that value is correct, then we get out of the loop, otherwise we'll loop back and request for more. So what are the two problems that occurs when a character is entered when a float or an integer are being expected? Remember there were two issues that happened. The first one, that would be a flag, error flag on the input buffer indicating that the operation was not complete because there was a mismatch. And then the invalid characters would not be extracted from the buffer. We will have to fix those two. So what will be the end result of these two problems if your program does not take care of them? So we'll go to an infinite loop, right? Because the characters were never removed from the buffer. And if you don't clean the buffer, then we'll still have those forever there. What are the two steps that we need to fix then? So we just discussed that in high level. The first, we have to clear the flag on the buffer, which is scene.clear. Then the second one, we're gonna have to remove the invalid characters, so we'll have scene.ignore. Then here we're using numeric limits, the string size, to provide the maximum size of the buffer, and then /n is the end character for the line. So what it does if not seeing extraction n1 will do for us. So it does two things. Remember, we discussed the first one is going to return the status of the operation, which was the status of the extraction. If the extraction failed because there's a mismatch, it's going to return false. If the extraction succeed, you'll return true. In addition to that, if the extraction succeed, you already return the character for us or the value we're expecting num1. So checks if the input is valid. At the same time, if it is valid, it performs the extraction. What does numeric limit do for us? Okay, it will determine the size of an implementation specific type. So in this case, it's trying to find what is the larger size for us of the buffer when we use numeric limits. What do we need to include or not include lists of files when we use numeric limits? Right, we're going to include the limits. What does string size will do for us? String size allows us to provide the size of the input or output string buffer. So in conjunction with the limits, we'll be able to find what's the maximum size that we needed to extract if there is a mismatch. What do you need to include when we use the string size? Right, we need to include iOS. True or false? When you run a do while loop to check for valid inputs, we should run the loop based on the range of the inputs that are invalid. In other words, what we're doing is that if the input was invalid, we should stay on the loop. When the input is valid, then we get out of the loop. Right, this is true. That's how we process that.